Good morning all children. Today again we are on the problems based on more than one function. Actually we have started the chapter exponent and powers. In my last lecture I have told you so many laws of the exponents, and according to that actually we have solved 2-3 question also. Okay, and in the same series again we are going to solve some of the typical question which are actually based on the exponent, and these are the questions wherever students feel some kind of the difficulty. Okay, why? Because such kind of the questions are problem based on more than one function. It is the question which is generally asked in the board exam for the 8th class students. That's why you have to be very much careful. Okay, see the question right now. Question number 1 is says that find the value of x. Students, when I am giving you the trick, whenever you are seeing any kind of the question, first you should read the question. What is the requirement of the question and what is given to us? So first we have to see. Okay, 3 upon 7 power 3 into 3 upon 7 power minus 8 is equal to 3 upon 7 inside in the power it is written 2x minus 1. So I have told you in my last lecture also what is our first concentration. Whenever we are solving the exponent, first we have to see either the bases which are given to me, they are equal or not. Okay, so what are the bases here? 3 upon 7, generally bases are written in the bracket, inside the brackets. So 3 upon 7, 3 upon 7 and 3 upon 7. Okay, first step is clear, and after that again I have to see actually the right hand side. I need not to solve the right hand side. Why? Because directly I will compare the exponent. Only I have to solve the left hand side, and after all when it is converted into the single exponent term, then only I can compare the power. Okay, so I will see here. What is this particular case? It is the multiplication case. You can see 3 upon 7 power 3 into. So which particular formula will come into role right now? So a to the power m into a to the power n should be equal to a to the power m plus n. Means when the bases are equal, so generally what we do, we add the exponents, we add the powers. Okay, so that particular rule we will apply here. 3 upon 7 m, in place of m 3 is there, in place of m you can see minus 8 is there. So directly I am writing, I am not putting bracket right now, so 3 minus 8 directly also we can write down. Why? Because if one of the exponent it is negative, meaning is that addition is not possible yet, so directly they will subtract from each other. So 3 minus 8, same to same I will copy paste 3 upon 7 2x minus 1 here also, no change. Right now see again copy paste will be there, 3 upon 7 2x minus 1, no change, because only I have to solve left hand side. 3 minus 8, 3 minus 8 indicates me I have to subtract 3 from the minus 8, so it will give me minus 5. Why? Because the negative exponent is bigger. Whenever we are doing the subtraction operation, and if the negative integer is more as compared to the positive integer, so my answer will come in the negative form. So minus 5 will be there, and here same to same. Right now I have told you one rule, and according to that particular rule, this is the equational exponent law, you can say. So if a to the power m is equal to a to the power n, meaning is that if in the equational form bases are same, so we can compare their exponent also. Okay, their exponent should be also equal. So m should be equal to n. So I have written here comparison of the base. According to the comparison of the base, if the bases are same here, 3 upon 7 and 3 upon 7 both the sides, so directly I can equate this minus 5 should be equal to 2x minus 1. So no problem, 2x minus 1 I am writing on the left hand side, so that it will become easier for me to solve. Why? Because it is the variable term, so generally I am keeping it on the left hand side. 2x minus 1 should be equal to minus 5. Equation law I have to follow, 2x should be equal to that minus 1 will come here, and whenever we are solving the equation, so what is the quantity that is transferring to the another side, it is changing the sign. So minus 5 plus 1, minus 5 plus 1 will give me minus 4 here, and when I solve 2x is equal to minus 4, so I will get x is equal to minus 4 upon 2. 2 is in the into position, so finally it will go on the division position. My answer will become minus 2. So that was all the I have explained you thoroughly thoroughly. So this kind of the question generally asked in the exam. Another problem I have written here also, second question, and it is also little typical. See the things. What is given to me? 4 to the power x plus 2 is equal to 30 plus 4 to the power x. If you will look in the first reason, so what you can calculate at in your mind. Actually you will see here 4 to the power x plus 2 and here also 4 to the power x. So it might be some of the relation. Okay, 4 to the power x, it might be some of the relation with 4 to the power x plus 2. So what should I do first? Actually I should transfer this particular quantity on the left hand side. So that I have done in the next step. You can see is equal to 30, nothing, only transferring this particular thing to that side. So negative sign. In the next step you will see what it is written actually, 4 to the power x plus 2. Addition of the exponent. So this particular rule, I am knowing that according to the formula a to the power m into a to the power n. During the case of the multiplication, their power is generally added. So here I am applying that particular rule in the opposite form. Means a to the power m plus n is given to me. You can see 4 to the power x plus 2 is given to me. So what I can write down? I can write down this particular thing in form of the multiplication case. Means 4 to the power x into 4 to the power 2. Then only I will get from here only I am getting these both are equal to each other. Means if the bases are equal, so their exponent I can add here. And if the exponent is given to me in form of the addition form, so I can separate in this way also 4 to the power x into 4 to the power 2. So that I have done in the next step. Other things are same, you can see. Okay. In the next step, what is the case? Right now see 4 to the power x. This is my first term. Here minus sign is coming. So this is my first term and this is my second term. So in both the terms you can see 4 to the power x and 4 to the power x. It is the common term. It is the common thing. So what I will do? I will separate the common term. So I am taking the common 4 to the power x here. And if I am taking the common, so what is remaining here? 4 square minus actually 4 to the power x. I am taking common. So what is remained here? Nothing. And if nothing is left there, so what I can write down? 1. For that second term, what is remained? Minus 1 is equal to 30. If nothing is the case, right now the problem is converted into the easier form. See, 4 to the power x same, 4 square will give me 16 minus 1 is equal to 30. After that 4 to the power x into 16 minus 1 will give me 15. Okay, is equal to 30. That 15 I can transfer there because 30 is waiting for 15. 4 to the power x is equal to 30 upon 15. This will give me 2. From here the logic starts actually. Okay. Actually what I have to do at the last, I have to compare the powers. And first I have to make the bases equal. So see right now 4 to the power x is equal to what I am getting here 2. 30 upon 15 it is giving me 2. Right now again I will see either this is the 4 and this is the 2. Again the bases are not equal. So what is my next step? I will convert this 4 into the base of 2. So what I can write down in place of 4? Actually 4 can be written 2 square also. Because 2 2 ja 4. So I have written 2 to the power 2 whole power x. Again one more rule is coming into the role. See, a to the power m whole power n. Means if there are the more powers, so what we do? Generally we multiply both the powers. So a to the power mn. So it can be written 2 to the power 2 whole power x. So these both the things 2 and x, these are the two powers, these are the two exponents. So I can multiply this. So it will become 2x. Right now I can compare the powers. Why? Because you can see the bases are same. 2 is also here, 2 is also here. Here only 2 is there. No power is there. So if there are the no power, so what I can write down in place of it? I can write down 1 also. So right now by the comparison, a to the power m is equal to a to the power n. M should be equal to the n. So 2x should be equal to 1. From here I am getting the value of x, that is x is equal to 1 upon 2. One more problem I am solving for you. Okay. And this time I will solve it fastly. So be with me at your home. Again you can solve such kind of the problems. Okay. See the question. Minus 3 power m plus 1 into minus 3 again power 5 should be equal to minus 3 whole power 7. Again same kind of the question we are facing. So see from here, this is the multiplication case. So simply I am applying the same rule. Solution. a to the power m into a to the power n should be equal to a to the power m plus n. That particular rule I can apply here. Same kind of the question you can see. And bases are same, minus 3. So minus 3, what is the power I have to add? M plus 1 plus 5, nothing else. And this is the copy paste, nothing. Right hand side I need not to touch, because this will come into the role whenever I will compare the powers. Okay. Right now see, solve the next step, minus 3. This I can write down m plus 5 plus 1 will give me 6. And this is same, copy and paste, same to same here. Right now you can see minus 3 is here and minus 3 is here. Means bases are equal. So what I can do, I can compare the power. So I will write down comparison of the power. Comparison of powers. And after that only I will equate the power. M plus 6 should be equal to 7. And from there only it is very easier task for me to get the value of m. M value I will get 7 minus 6, and that is equal to the 1. And here what is the rule that is coming? M to a to the power m is equal to a to the power m. If this is the case, if the bases are equal and they are written in form of the equational form, and if the bases are equal, so their power should be also equal. This is the rule that I am not writing again and again, but you should write down while solving the question in the exam. So this is all about this. In my next lecture I will solve so many questions. Okay, thank you.